We're looking at lesson 5 today. The first thing on it says exploratory challenge. When it says exploratory challenge, it's asking us to just kind of try some different things out. This is talking about how far Giselle can run. So it says the distance Giselle can run is a function of the amount of time she spends running. She can run 3 miles in 21 minutes. Assume that she runs at a constant rate. Constant rate means she's not going faster at some point, slower at some point. She's going the exact same speed the whole time. So it says write a 2-variable equation that represents her running. So you're going to start with y divided by x. So hold on, I know you can't see this. Y divided by x is where you start. Remember, it's usually distance over time. So how far is she running? 3 miles goes on the top. Distance divided by time. It takes her 21 minutes. We've done this so many times this week and in module 4. So what you do is you cross multiply, figure out what y points to diagonally, and put those things together. Figure out what x points to diagonally and put those together. You want to solve for y, so whatever sits right in front of y, that's what you have to divide by. So we all have calculators. I know we do. So someone take 3 divided by 21 and tell me what you get. We're going to write this as a decimal. Is it 0.7 or 0.07? I don't remember. Okay. That's not what I got. Take 3 divided by 21 your calculator.
0.14.
Yeah. Okay, so this is the equation that we're going to use for Giselle running. Okay? He says use the equation you wrote to determine how many miles she can run in 14 minutes. So you're going to plug in 14 where x is. So how many miles can she run in 14 minutes? So take 0.14 times 14. Yep, she can run 1.96 miles in 14 minutes. That is way better than I could do. Good job, Giselle. Yep. Use the equation you wrote in part A to determine how many miles she could run in 28 minutes. You're going to take 0.14 times 28. First of all, I could never run for 28 minutes straight. You could? Really? Yeah, she can run 3.92 miles in 28 minutes. I could maybe run for 1 minute. And then the last one for 7 minutes. So we're going to take 0.14 times 7. .98 miles. So she is almost running a whole mile in 7 minutes. So she's about at a 7-minute mile. So she's about running a 7-minute mile. That's pretty good. Okay, now I want you to graph this. So it says for any given input of the function a time, the matching output is y. Write the inputs and outputs from part B through D in ordered pairs. So we're going to kind of round this up a little bit. Okay, so for 14 minutes, about how many miles can she run? 2. We're going to just say 14.2. Same thing here, 28 minutes, about how many miles can she run in 28 minutes? 4. And then for 7 minutes, she can run about 1 mile. So what I did there is I just rounded them up to the nearest whole number so that it's a little easier to graph. We're going to plot these points on our graph over here. So you're going to go, the first one we have is 14, 2. I know we had 7 and 1. 7 is actually in between 6 and 8, so you got to pay attention to that. Then we had 28 and 1, 2, 3, 4. Did I miss one? Or did we do them all? Yeah, we did them all. Okay, if you connected these, and I'm actually going to connect these with an actual line because I don't want it to look terrible, but if I connect my points, what do you notice about the line? It's what? Linear, it's a straight line. So what do you notice about the points you plotted? It is a straight line. I like that you said linear. That's a good way to put it. What we know is if she's running at a constant rate, that it should be linear. Like if she's not speeding up, slowing down, speeding up, slowing down, you should get a straight line. They want to know, is this function discrete? So think about it. When you're talking about running miles, can you run a half a mile? Can you have like a distance that is like or a time that's half? Yeah, so we're going to call this continuous because you're allowed to use halves and quarters and all of that. You can use decimals and fractions. Okay, H says, use the equation you wrote in part A to determine how many miles Giselle can run in 36 minutes. Write your answer as an ordered pair. Okay, so here's our equation. Y equals 0.14x. If we want to know 36 minutes, you'd take 0.14 times 36. So we have a calculator. Take 0.14 times 36 and tell me what you get. 0.14 times 36, you get 5.04, which we're just, going to round to 5. So then it says, is the point where you expected it to be? So let's go over 36 on our graph and see where it would cross. 1, 2, 3, 4, and my line's a little off. Hopefully yours is better. Let's see. It's close to right where it's supposed to be. Mine looked a little off because I didn't do my points all perfectly. Okay, moving on to G. No, wait, already did that. Moving on to I. Assume you use the rule described in the described function to determine how many miles Giselle could run for any period of time and wrote them as an ordered pair. Where do you think these points would appear on the graph? So let's, any amount of time, where do you think the points would end up on our graph? Should it end up on the line? Like if she ran in 46 minutes, where do you think it would end up? It should end up right wherever our point is on our line. So that's what we're going to write on I, is it should be on the line. That's not the word should. Here we go. So all of the points that we are doing, if we wanted to calculate a specific number of minutes this girl could run, it would fall on that line that we drew on our graph. What do you think the graph of all input and outputs would look like? Well, it was a straight line to begin with. What do you think it would look like if we would add more? It would still be a straight line. And the reason we know it would still be a straight line is because we have a constant rate. That just means Giselle is running at the exact same speed the entire race, which is very unlikely, but that's what the math paper says that she's doing. And the last ones, it says, connect the points you've graphed in a line, select the point on the paper, and verify that it works. So we already connected our points. We're going to go back to our graph. I'm going to look and see, and I'm going to see at 6, up here, here's 6, where would it fall? So if I plug in, what letter are we on? Okay. I'm going to plug in a 6 for y and see how many minutes she could run 6 miles. So all we have to do is divide this by 0.14. So someone take 6 divided by 0.14.